Hello class. On the screen is your activating strategy. Which one doesn't belong? Consider the images. I'm going to give you 10 seconds and then we'll be back. Great. Let's consider what we've been learning. We've been learning about scaled images. And we know for a copy to be a scaled version of the original, it has to be the same shape. It can be larger, smaller, or a duplicate, but it must be the same shape, as in it cannot be skewed or distorted in any way. Because of this, we know that C is the odd one out. It is the one that does not belong. It is the only one that is not a scaled copy of the original. Today, we'll be working with drawing scale copies of a given figure using a given scale factor. The video below is available for you to rewatch at any time. You can watch this whenever you feel like it and just to review. I, of course, will be walking with you through the rest of the slides. So here, they want us to draw a scale copy of either figure A or B using a scale factor of 3. And I will choose to use B. So I'm going to reproduce B using a scale factor of 3. So I'm going to start with this piece here. This piece is 1. The scale factor is 3, which means I must multiply 1 times 3. That means that new line must be 3. So I'm going to start somewhere here and I'm going to go 1, 2, 3. Okay, that seems easy enough. Then I'm going to look at this line here. So this line is 1, 2, 3. And 3 times 3 is 9. So I must go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. Awesome job. We also have a diagonal here. So I see that this diagonal goes over 2 and it goes down 1, 2, 3, 4. And I must apply my scale factor to the diagonal in that way. So instead of going over 2, 2 times 3 is 6. And instead of going down 4, 4 times 3 is 12. So I'm going to go over first 1, 2, 3, 4, 5, 6. I'll put a die here just to let me know. And then it has to cover from here 12. So I have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 9, 10, 11, 12. So it will be here. So it's going to go from here all the way to here. Now it's not going to be perfect because I'm freehanding. But if you count, the diagonal goes across 6 and down 12. And now we're going to count this line here. So we're going to go 1, 2, 3, 1, 2, 3. And we're going to apply the scale factor of 3. And 3 times 3 is 9. So we're going to go up 9 from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're here on this line. So it has 1, 2, and we're going to apply the scale factor of 3. 2 times 3 is 6. 1, 2, 3, 4, 5, 6. And there you go. We have duplicated B by scale factor of 3. You should try it with A. If you tried it with A and you got that outcome, great job. Let's try reducing it. When you have a scale factor that is less than 1, the new item will be smaller. If you have a scale factor that's greater than 1, it will be bigger. And a scale factor of 1, you will have the exact same shape. Here, our scale factor is 1/2. So we are reducing this by half. And I'm going to do C. I'm going to start with this line here. So here we have 1, 2, 3, 4, 5, 6, 7. And we're going to reduce it by half. So 7 divided by 2. We know that 2 can go into 7 3 times, because 3 times 2 is 6. 3 times, and we will be left with a half. So this new line would be 3.5. And I did it this way because 7 times 1/2 is the same as 7 over 2. Okay? So we know it's going to be 3.5. I'm going to start 1, 2, 3.5. So it's going to be halfway between this one and this one. Here we go. That's 3. 1, 2, 3.5. We have 1, 2. 2 divided by 2, or 2 times 1/2 is 1. And we have 1, 2, 3, 4. We have 1, 2, 3, 4. 4 times 1/2 is the same as 4 divided by 2, and 4 divided by 2 is 2. So we're going to go 2, but because we have a half here, it's going to be 1/2, 1 whole, and another half. And that is going to get me 2. Here we have 3, and 3 divided by 2, or 3 times 1/2, is 1.5. So we're going to go over 1 and 1/2. That's going to get me here, approximately. Then we have this piece here, this one edge here, and that goes up 2. And 2 times 1/2 is the same as 2 divided by 2, and that will go up 1. But because I am in half, it will go up between the half. Awesome. And now this piece here is 1, and 1 times 1/2 is 1/2. And this piece here, we have 1, 2, 3, 4, 5. And 5 times 1/2 is 2 and 1/2. We got 2 and 1/2. And then across the bottom we have 1, 2, 3, 4, 5, 6. And 6 times 1/2, or 6 divided by 2, is 3. And this is what your new scaled item would look like, a smaller version of the bigger one. You should definitely give this a try with D. Here, we're going to be drawing scale copies. Jada wants to scale the polygon so that the side that corresponds with the 15 units in the original, here is our original, is 5 units in the scale copy. We are going from a larger number to a smaller number. And we all know, because we've discussed this before, that in order to shrink, that the scale factor must be smaller than 1. Let's complete Jada's drawing with the approximate measurements. And this is our copy. Good job, Jada. So 15 must correspond with 5 units in the scale copy. So this is 5. Because the equation is copy over original, and the copy will always be on this side. The copy will always be here, and the original will always be here. Copy over original, we have 5 divided by 15. And we know that 5 goes into 5 one time, and 5 goes into 15 3 times. So our scale factor is 1/3. I'm going to erase this because this is currently covering our polygon. But our scale factor is indeed 1/3. Remember, the copy is always here, and the original is always here. So utilizing that, what we know, we're going to take this line here, so 18, and we're going to multiply it by 1/3. And because we know that multiplying a whole number by a fraction that has 1 in the numerator and a number in the denominator, it is the same as taking that whole number and dividing it by the denominator. So 18 divided by 3. 18 divided by 3 is indeed 6. So the side that corresponds with 18 would be 6. And we're going to do the same method for 36. So 36 divided by 3 is 12. So the side that corresponds with 36 will be 12. Now we have 30, and we're going to take 30 and we're going to also divide it by 3. 30 divided by 3 is 10. So the side that corresponds with 30 will be 10, and we have 21. 21 divided by 3 is 7. So the side that corresponds with 21 will be 7. And that is how we apply our scale factor. We take the copy, aside from the copy, and we divide it by the corresponding side from the original. And we utilize that number and we multiply it by the original sides to find the remaining lengths. So here is an opportunity for you to show me what you know. Make a scale copy of the figure below utilizing the scale factor of 2/3. It's smaller than 1, so you know it will be a smaller version of what you see. It is also a fraction of 2/3. That means you take the length, you divide it by 3, and then you multiply it by 2 to find your new length. We've been working on that since the beginning of school. And your practice for today is your justified true false. This is something that you have access to in your Desmos Math. So you can do that there. You do this here. It's due on Monday. And there is a copy in the Google Classroom. And more scale copies. Triangle Z is a scale copy of triangle M. Select all of the sets of values that could be the side lengths of triangle Z. Your best bet is to take these different side lengths, figure out what they correspond with. So it looks like the smaller number would be this part. The second largest number would be this hypotenuse here. And then the third largest number would be here. See if any of them have corresponding or the same scale factors, as in from 4 to 8 would be multiplied by the same, from 7 to 11 would be multiplied by the same, and from 10 to 14 would be multiplied by the same. And you would do that across A, B, C, D, and E, and you would let me know which ones, because it's more than one, could be set values and side lengths for triangle Z. All right. Good luck in the quiz today. Don't forget to have your homework on Monday, and you enjoy the rest of your weekend.